Chinmay Chinara is pursuing a master's degree in image processing and computer vision at USC, from where Greg Feingold recently graduated. I'd like to call you both up here.
Hey everybody, thanks for coming. So we're here to talk to you about ARnold, which is an AR short film made for the Microsoft HoloLens. And so here's the team. So this was, I'm the lead producer, and it started out as my thesis project at USC. I studied film production. And then Chinmay and Akash are our technical leads, and then Casey was our kind of creative producer. And so we all found each other through VRSC, which is a VR AR club at USC. And we came up with this concept, and then we pitched it to the USC has this Institute of Creative Technologies, and specifically they have a studio at USC called the MXR Studio. And so we pitched it to the professors Todd Richmond and David Nelson, and they liked it, so they kind of took us under their lab. So that's where this project was developed. So before getting into it, I want to give you guys a little briefing if you don't know about kind of the state of AR technology, as in what's available on the market right now. So kind of, this is kind of in scale of how immersive the technology is and how complex it is. So at the bottom is kind of the newest technology, which is AR Core and AR Kit, which is for Android and iOS, and respectively. And these are software development kits that are for mobile AR. And so you look through your camera viewfinder on your phone or on your tablet, and then it will place virtual objects over the camera overlay. And so these softwares only really do two things. And so one, if you place a virtual object in the real world, it'll stay in one place for a very long time. So I could put a Pokemon on the ground, and then I could run around it in a circle, and it would still stay placed in one location. And then the other thing it would do is it will find a horizontal plane, and it can place objects on that horizontal plane. So if I was to move my phone around this table and up and down for a while, it'll recognize that as a horizontal plane in the real world, and then I can place objects like a chessboard or a Pokemon on top of it. And then going up these are HMDs, or head-mounted displays, Magic Leap, Daiquiri, Meta, and ODG. And so these are displays that you can wear on your head, and they're either a clear visor or a pair of glasses, and they'll also overlay these virtual objects on the real world. And so these aren't quite at the level of the HoloLens. Some of them are wired. Most of them are for specific use cases, like enterprise, or for building things, or for like the healthcare sector. And then the very top is the Microsoft HoloLens, which was released a few years ago. And so this is it's a wireless Windows 10 computer that you can wear on your head. And then it also has a camera array that is constantly mapping the world around you and then placing virtual objects on this. So it's kind of widely agreed that the HoloLens is, in terms of technical specifications, it's kind of the best in the market in terms of AR. So that's where we started this project with. And so when we were just developing this ARnold concept, kind of the birthplace of the idea was we looked at all this technology, and we wanted to ask if we could make a film that was told using augmented reality technology. We saw that these headsets were being used in a ton of different areas. Obviously AR is being used in games, something like Pokemon Go. It's being used in healthcare. Doctors are wearing HoloLens in hospitals doing surgery. It's being used to build Teslas. We have people manufacturing Teslas, and they're wearing the headsets, and I'll tell them where to put the pieces. But we couldn't find any examples of specifically telling a story using augmented reality. So that's kind of the challenge that we took on with this project. So the basic concept of ARnold was, can we tell a short film that takes place in the world around you and adapts to your surroundings? And so the story of Arnold is this dog here. And Arnold is a dog that one day appears in your living room somewhere. He pops out of a box, and suddenly he's your dog. And so we told this story because we wanted to come up with a story that is attached to a room that you actually have in your house. So we asked a lot of people questions, and we found that when people have pets, they're very intimately connected to their homes. You go home, and then you find your pet there. So we felt that telling a story about an augmented pet really fit nicely with this sort of augmented reality type of storytelling. And so the story is the dog, over the course of like 5-10 years, the dog's lifespan, he's always trying to escape your house. And at the very end, he does escape your house, but it's really rainy and wet, and there's a thunderstorm outside. And so he immediately runs back inside, and it turns out where he really wanted to be was at home with you all along. And we got this story from talking to a lot of different people and a lot of friends, and we found that this was something that happens a lot if you have a dog, is it always wants to escape, especially when you get a brand new dog, and then it does, and it turns out, yeah, the real world kind of sucks. So since this is a research project at the Institute of Creative Technologies, we came up with a few specific research goals for this project. So we split them up into technical and creative. So in terms of technical goals, we wanted to place the scenes seamlessly in the environment, because it's not really true augmented reality unless you don't really know which is augmented and which is really part of your reality. So we wanted you to look around and you're not sure if that cardboard box that just appeared in your room is part of your room, or if it's like part of the augmented reality display. And so that involved a lot of tracking the room and mapping the room and placing objects firmly in a space in your room. The other technical goal we had was that your character is going to interact with your surroundings. And so this means that not only are we placing like this dog in space somewhere, but that it uses this map of the surroundings that we build, and then it interacts with them. So it's jumping off tables, it's jumping off chairs. And this kind of lends it to immersivity. So at this point, you're not just telling a story about a dog, you're telling a story about this dog that is your dog, that is in your room, and interacting with your objects. It becomes not a story, it kind of becomes your story, and it's going to be different every time. And then in terms of creative goals, we wanted to craft a story that's perfect for AR. One of the biggest challenges with AR storytelling is there's a lot of things you can't do. Your toolbox is very limited to objects, characters, maybe a few props, but you can't create a backdrop, you can't create a world around you. We couldn't tell a story, for example, that's about like creatures in the jungle, because we can't throw you in a jungle with an AR headset. Otherwise, it would just become like a VR experience. So telling a story that can be told with just a few objects and that makes sense no matter where you're watching it. And then our other creative goal was, can we create a more sympathetic character through AR? So one of the biggest hypotheses that we had when we went into this project is that if we make this augmented reality character that is interacting with the things around you, that looks like it's part of your world, that you're gonna feel more connected to it, you're gonna remember it more. And so in order to achieve all these goals, we had to do a lot of technical stuff behind the scenes. So I'm gonna hand it to Chinmay, who's gonna talk a little bit more about that.
Thank you so much, Greg. Before we move into the technical nitty-gritties, so we started this like a year back, and we kind of developed the complete project using the Microsoft HoloLens Toolkit, which was then at a very nascent stage, and currently it has been evolving ever since. So with respect to all the things that has been done in this, with respect to technical successes and everything, the technology goes back to maybe 6 months back, so things might have changed a lot in due course. So let me just speak about what we have done then. So there are different things that we achieved. First being the spatial mapping, understanding. I'll talk about each of them separately. Then about spatial anchors, magic window, voice recognition, spatial audio. So all these things are the successes that we had. So coming to the very first thing, that's the spatial mapping. So here you can see in the video that we're actually doing real-time tracking of the complete environment around us. So this is the first step that we took, where we mapped the complete surroundings, and we made sure that all of the objects are properly scanned, so that like around roughly 500 triangles per cubic meter was like the parameters that was set for us, so that we have efficient generation of mesh that can help us for doing the tracking and the understanding. So that was the first thing. And the amount of details in the triangle mesh actually ensured us that we had a very good object recognition in the end and the spatial understanding. So that was what was also taken care of, so that we kind of scanned. We took like a scan for like 5 minutes or so that we ensured that we had everything that we wanted to. So coming to the spatial understanding, so if you see in the video to the right of you, so this is what we had. This is kind of this play space that we simulated. And from the data that we captured from the spatial mapping, we used different APIs that the HoloLens Toolkit provided. Like we had topology and shape queries that has been already defined by the Microsoft team, and they had DLLs defined for it. So like you can see in the video, like once we had the scanning done, you can see like it detected the wall and the floor. So let me just take an example. So like, how does it detect the floor? So the floor is like, the logic that it uses is like it just scans the largest and the lowest horizontal surface with maybe an area greater than 1 meter square. It considers that side of the floor. So these kind of topology and logics were used to detect different objects. For the couch, if you see a couch, it effectively scans the area, the sittable area in the couch and the rest area, the back of the couch, and it kind of combines with all these shape queries and topology queries to give you an estimate of a couch. So stuff like these were used to do spatial understanding. And again, so everything depends on the initial scan that we do. So we ensured that we had a very good mesh. That's what I had been constantly telling you in the previous slide. So we took our time to scan the surroundings and have a complex mesh generated so that the object recognition and everything became pretty much flawless. So these are some of the things that you can see. So this was one try test that we did in the initial. So you can see we use spatial understanding. So mapping and understanding has been done. And you can see all the chairs around. And this was actually a rough animation of Arnold, actually. So he's just present in all the platforms that were detected. And this was the jump motion that we simulated. So let me come to it. So what we actually wanted the user to be immersed in the environment, right? So we wanted him to feel that it's his own dog. So this is one simulation that we did where we actually had the chair being scanned and let the dog jump from the top of the chair to the floor. So this was kind of a programmed simulation that was done. Now come to spatial anchors. So this was one issue that we observed in due course of the development of a project where we had a lot of demonstrations done, a lot of feedbacks gathered. So what happened is every time, like our story is based on scenes. So every scene has some animation being played. And spatial mapping and understanding requires us to actually take the real-time positions of different places that you want. So maybe a position on the floor, a position on where the chair is. So what is happening is on every scan, because the scenes were being changed from one to another, so the previous data that was stored, the positional data was being lost. So what happened is like maybe the door was where the wall is, but in the next scene the door was maybe in thin air. So using spatial anchors, we defined a common frame of reference where we had an anchor and all the positions of different objects were placed with respect to that anchor. And the beauty of this spatial anchors of Microsoft HoloLens, it does not get deleted unless you totally reflash your app. So using this, we were able to actually have a single frame of reference and in the real world coordinate system. And so only one initial scan was required once you had your app on the HoloLens. And after that, you just rerun your app and everything falls in place. These last 2 points actually are very important because HoloLens has a maximum battery life of like 3 hours. And if you want to have a lot of demonstrations done, so you should make sure that the battery continues, right? So when you had to rescan every time initially when the initial app development was happening, so we didn't have the spatial anchors incorporated. So with if you wanted to have demonstrations, we needed, like before giving it to the user, we had to actually scan the room and every time let the user scan it and do it. So with this scanning process consumed a lot of battery and it used to drain a bit because you had to generate meshes. And all the depth sensors that are present in the HoloLens were being used. So the more number of sensors hardware being used, more is the battery consumption. So to avoid that, this spatial anchors actually helped us in removing these, do these kind of effective battery power management, and it really proved useful. This is another concept of the magic window where we kind of use the occlusion feature. It's like you can see a virtual world beyond the real world. So if you can just pop through you can pop your head through the door and you can see that's what we call the magic window. Next, we use the voice recognition. So we didn't want a story to have the user to continuously tap have some gestures to actually control, because we wanted it to be a story, not a game, right? So we wanted the user to feel connected to its own dog. So we wanted the user to summon the dog and let the story start. So this is what we did. So we removed it, we replaced the gesture-based commands and we used the speech recognition APIs in the Microsoft UWP to actually develop these so we had the spatial mapping done first, then the understanding. Then we had a voice command say here boy is what the command is, and the story begins. So this kind of aided in blurring the line between the virtual and real world by creating the effect of summoning a dog. So the user felt more connected to the dog. And coming to the spatial audio. So this was, again, another thing that we learned in due course. Initially, we had all the audio that is present in the story to be, not at all spatial. So the audio was just at a constant location. So we wanted a user to explore the story, but because the scenes were very short and the user did not get enough time to actually look around and look for the dog. So what we did is we incorporated the concept of spatial audio, where all the audio was based on all the moving objects. So like the dog was moving around, right? So we placed the audio into the dog with all the spatial effects using Unity. And this allowed the user, because the HoloLens has the spatial hardware in it, the spatial audio hardware, so it allowed the user to get directed to where the dog is. And he was actually able to find and relate to the story. So this was what we achieved in that. So it helped in tracking the continuous motion of the different game objects. It gives a better sense of direction to the user. And you can actually use the immersive headsets for better experience. Like this, I'll tell you about why I quoted this particular point. So this was the technical challenges that we faced majorly. One was like the HoloLens, like it's a known fact, the HoloLens does not work in poor lighting conditions. So room scanning with poor light was really a big issue. Next was the object recognition. Sometimes it failed, and then the noisy environment. So this was the room scanning with poor light. So this was where we tested, like we just had one light bulb. So even though we are trying to scan the room, we're still not able to generate the mesh. That can be seen in the video. It takes a lot of, see, there are just, some traces of mesh and stuff. So this was really, it was really, sometimes it really failed when there was poor light. Next comes to the object recognition. Now you can see, I showed the same video before, but you might have not seen it properly. So now if you see it clearly, there are dogs in certain locations, but I expected dogs to be there in all the different chair locations. So, but if you see it, it's like just there in few locations, not everywhere. If I can just play it again. Yeah. So you can see the dogs are there, but there are some missing chairs as well. See, these two chairs. So yeah, stuff like this. It's not that every time it worked very fine. It all depends on how good a mesh you have in the initial stage. So the workaround, we made sure we had sufficient lighting conditions, and so that the complete scanning and the mesh generation became flawless. And we had a dense mesh so that the object recognition took place good enough, and immersive headsets. So this was the problem of it, noisy environments. So what happens is we had to actually summon the dog, right? So we had to give a voice command. Now if there are a lot of people in the room and there's a lot of noise, then this is where the HoloLens, again, fails very badly. So we made sure that we had users wear immersive headsets and perform all the storytelling activities so that things happen in proper order. So that's one way to look around it. Working with continue, I would hand over to Greg, if you can continue it.
Thank you. So I'm sure everyone in this room knows about working with technological constraints, but we can talk specifically about augmented reality constraints because there's a lot of them. And it informed how we started the project creatively and how we ended it. So we actually started this project, it was called Home Invasion. It was a spy thriller. There were spies coming in through your house, through your windows. You had to hide under your couch. And then we prototyped it, and if you've ever used a HoloLens, the field of view is about this big. Imagine holding your phone right here. That's what it looks like to look through the HoloLens. So in actuality, you wouldn't see a spy coming through your window. You would see his torso coming through your window, and then you'd see his ear coming through your window, and you'd have to look around a lot. So it turns out that right now AR storytelling doesn't really work if you want to tell stories about full people, and that kind of carries over to mobile AR as well. You don't want to have your phone held up and scan up and down or be 5 feet away from a story. So that's kind of why we made the story about a dog, because the dog is actually the perfect size to always be in the field of view, and it actually has this added benefit of being something that you're always emotionally connected to. So yeah, that was the field of view. Also, AR is a one-room experience. So if you guys have seen the Black Mirror episode where it's an AR experience, it's all over this spooky haunted house, and you go into different rooms and different things scare you. Unfortunately, we can't do that right now. We could see how in the future we could do that scanning technique and walk through the entire house and scan it, and then create an experience based on that. But right now, HoloLens can only kind of generate one thing in one room. And the same kind of thing with ARKit. It can only generate one like plane at one time. So you can't really build these full immersive, like building size experiences yet. And then a final thing is there's not really a full object database that we can pull from that can generate different experiences. So we imagined at one point telling the story where we'd tell a different story based on if you had a table versus a couch versus a chair. But if you saw in our demos, we really are only tracking different platforms at different heights. So that's another limit, is that the database doesn't just exist, it just doesn't exist yet. There's some things, the Microsoft Holo Toolkit has some kind of database, and also OpenCV has a computer vision database, but they're just not there yet until where we could pull from it and use that to create an experience. And, but we had a lot of creative successes and ways that we found out some new ways to tell stories in AR. So one of the biggest things is people had empathy for this character. People always remembered the name of the dog. People always could tell you what happened in the story. People started calling it my dog Arnold, or like, oh, that's my dog right there. People would say, if someone was experiencing it, they'd call someone over. They'd be like, look, it's Chester, and they would relate it to their dog as well, because it's right in front of you. People were sometimes too immersed in the experience. You saw the magic window thing. We had so many people running into walls because they thought they could walk beyond that door that was augmented. So that was an unintended side effect. And also each story was a little bit different. So Arnold would jump off of different objects, and Arnold would interact with your room in different ways based on what that mesh that we generated at the beginning of the experience saw. So that means that everyone had a different story based on the room that was around them. So your environment dictates the story, which is something really important. And then just really quickly, if you see these three images in the bottom, so these were new storytelling techniques that I kind of came up with in order to tell a story in AR. So the first challenge that we had was you can't direct someone's attention in AR like you could in a film. You can't have different shots. You can't have a tracking shot. Because when you're wearing an AR headset, you can look wherever you want. So that's a challenge as a storyteller. So on the left, you see a fade. So we try to do something like a fade to get people to gradually like watch a story as it unfolds. So we use these objects as books. So we'd pop in one book would fade in, and then the next one would fade in, and then the next one, and then we'd fade in the whole scene. And what we found after testing that a lot is it actually did guide people's attention. So you kind of watch the objects as they like unfold in AR. So we would test this over and over and over again, and every time someone's view would go from left to right and watch the scene unfold. So we've kind of directed the user's attention. The second one is spatial audio, and Chim, I talked about this a little bit, but we used it very specifically to find the dog. We had a little dog running around a big room. A lot of people would lose the dog. So with spatial audio, if you hear barking over there, you're going to look over there to see what it was. So people always could keep track of the story, even though they don't always see it in their field of view. And then the final one is that magic window technique, and we specifically used that in our story to expand the world. So not only are you in this living room, but you're in a living room and outside there's this huge thunderstorm and it's raining, and you can actually look out of this magic window and see that real world. So that's something that you can only do in AR, even though you're still in your living room. And just one more thing is kind of how we envision AR storytelling in the future. And in the future, that field of view problem, all of those technological challenges are going to get better. And so what can we do once we have this true immersion? One of the biggest things you can do is we can break these barriers between the virtual world and the real world. And we can bring things that at one point were totally foreign to you and make them suddenly like in your living room and like something you have to face. Sometimes these are going to be harsh truths, but they're things that I think that we need to get people to see. So for example, this is a project by Asad Malik called Holograms for Syria. It's a really cool HoloLens project, and what he did is he took these graphic, visceral images from Syria and from the Syrian conflict, and he put them in everyday situations using the HoloLens. So you would see, you know, like a mother and her children who are refugees, but he would place them like in your supermarket. And so seeing these things that like are normally so foreign and alien, and you read them on the news, but you don't really understand, like, what does that have to do with me? We can use augmented reality and this true immersion to get them into your real world and make it something that people are going to have to address. And we have one more thing. So Arnold is now on the App Store. We mentioned ARKit at the beginning, and so when ARKit came out a few months ago, we wanted to spread our film as much as possible. Because right now there aren't a lot of HoloLenses out there, so if I wanted you guys to be able to watch the film, it'd be pretty tough. But with ARKit, we were able to do not a lot of the technological things that we did here, but a few of the technical things. We were able to take our favorite scenes from the film and put it in an ARKit experience. So if you have an iPhone or an iPad that's running the newest version of the software, if you search Arnold and AR short film, you can download our app. It's free, and you can watch the film in your living room, and Arnold can try to escape your living room as well. And that's all I got. If you guys have any questions, let me know. Thank you.
Yeah, my name's Dale, and can we address the lighting of the mapping? You said that poor lighting was a problem. Would you suggest theatrical lighting out of camera range, or lighting as within the frame, like a table lamp, or a camera lamp, or a camera light?
So when you're talking about lighting, it's the lighting of the environment. So it's all about how the lighting conditions in the environment are. It's not about the camera lighting or about anything on specific to the HoloLens. It's the lighting of the environment where the HoloLens is in.
Okay, so you're suggesting that you raise the level of the room light.
Exactly.
So that's another one of those things that'll be fixed over time. I would guess that the next version of the HoloLens or any other AR headset that comes out is going to address that issue. It's just it's a little too transparent when you look at it under like direct sunlight.
And is it the deep shadows that are the problem, or the lack of, or which end of the spectrum right now?
So when you say lighting, so it's just about this kind of a level of maybe having a tube light in your room or stuff, something of that sort. So it's not about the shadow and about anything. So if it's dark, if it does not look enough light, it does not work. That's what the definition is.
So you're talking more of a multi-point lighting system within the room itself.
Exactly, within the room itself.
Multiple light, multiple source.
Exactly.
Okay, thank you.
In the iOS version, does it still go through the scanning of your room and?
Yeah. So in iOS, ARKit only recognizes like one horizontal plane at a time. So basically, you'll just scan a horizontal plane. We ask you like scan your floor, and then you place the door that Arnold is trying to escape from somewhere on that horizontal surface, and then everything will happen on that one surface. So it's not going to recognize any chairs like in the HoloLens experience. It's not going to do any of that. It's just going to, we kind of placed a bunch of our scenes on this flat surface, and then you can watch it in your room.
Just to add to that, so it's such a technical limitation that currently the ARKit has. So it just scans the horizontal surfaces. So now the actual thing that we did in HoloLens is we scanned the vertical and the horizontal surfaces for detecting where the floor and the wall meets, right? So that a door can be spawned. What here we are doing is we're just scanning the floor, and we're prompting the user. So there is you'll have a blue rectangle that will be continuously scanning the room, and we just make sure the user positions the rectangle so that it meets, so that it touches the intersection between where the actual wall is and the floor is. And he can just tap that and the door just falls into place. So it's just a hack that that has to be used because there's no other option currently.
It's a very interesting experiment you've done, and anxious to see a little bit more. But I'm wondering, for other researchers or other hobbyists, filmmakers who wanted to experiment with this sort of thing, kind of taking your model and then continuing, not necessarily your room and your pet, but your model of building an environment. Are there any tools, and perhaps you can use this question to tell us a little bit about how you design things like the objects in a room. You said, chairs and tables. Did you design all of those and draw them to put them into your story, or, and maybe this is just imagination at the moment, is there a way to use some of the online tools that are in the public domain? I'm thinking in particular like there's programs like SketchUp, for example, where there are huge catalogs of things that people have drawn. And so, oh, here's a table saw. Oh, here's a vase. Here's a sink. You could use those things instead of having to build your own for your movie.
Yeah. So actually, all of the models in Arnold were not created by us. We either bought them from one of those companies like Sketchfab or Turbo Squid, or the very basic ones we created ourselves. But that's what we did is we just got those from online and put them into Unity or Maya. And so Unity kind of runs a lot of the stuff in our app. And right now, the challenge for us was not any of the art creation. It was all about like the placing virtual objects in the real world. And so that's the kind of stuff where it's going to be a little difficult for a hobbyist to jump in. Holo Toolkit, which is Microsoft's SDK for Unity, is pretty difficult to use. That's what we made most of this with. And then ARKit is limited, but it's a lot easier for people to use. If someone knows Swift, a programming language, then they can kind of do it all in that. And I think over the next few months, you're going to see like more and more tools that'll make it easier and easier to take these art assets and then put them in the real world. Something like Wikitude and Vuforia also kind of help with stuff like that.
Is there any application for something, or maybe it's an avenue to be followed, for something like Minecraft, which is kind of a world environment of constructed stuff?
Yeah. So Microsoft actually made a version of Minecraft for the HoloLens, and it's pretty cool. I'm not sure how they made it exactly, but yeah, that's more of like a tabletop mode of AR, which is basically you scan a table and then it places the game on the table in front of you, and then you can interact with it like that. And that's not something that we addressed. Ours was more room scale, but that's another really cool application of augmented reality.
Can the programs mentioned there, like SketchUp and Turbo Squid and those things, be used not necessarily for things put into the world, but for recognition of things in the real world?
Could you elaborate?
So if you have something that basically creates a library of real world so that you can see those chairs and then you can recognize that within a program like HoloLens, to where it sees something that was modeled and puts that mesh together with a model that is existing in the real world.
Yeah, we can. That's definitely possible. So, like, if you have the mesh that's already, recognized, and you can just match it with the database that you have in the SketchUp, then definitely it's possible.
Okay. Makes
It's
it
it's part of
recognizable.
OpenCV or stuff, image processing stuff. So yes, it's definitely possible.
And that could help Arnold then jump onto the chair
Yeah,
properly and know that it
definitely.
is a chair. And then the other thing that I'm wondering about is how you get around the storytelling within HoloLens when so many of the items appear transparent when you're looking through the HoloLens and they have a kind of glowy feel to them within the HoloLens.
Right.
How does that affect the immersion?
It definitely affects it. That's not something we could work with right now, but immersion is definitely an issue. Like a related issue is just like the magic of seeing something in a HoloLens sometimes would overshadow the actual story we were trying to tell. And so both of those issues, you put a HoloLens on someone for the first time, their reaction isn't going to be, oh, I should follow this story. It's going to be, whoa, AR is crazy. So both that and the limitations of how transparent it looks are something that we just kind of had to work with right now.